All right, so the first question has to do with partial fractions. So we've done that before, but I'll just go over it. If you have, let's have a look at this. So we know this is a on 2 minus v plus b on 3 plus b. So what we could do is just hide the 2 minus v on the left. And really what we're doing when we do that, remember, if we're hiding this one, then we're really just multiplying both sides by 2 minus v. And you can see that when we do that, that we just get an a on this side plus a b times blah, 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 blah. And we can sub in that a 2 to make that bracket up here 0. So we can get rid of the b. So we do that on the left as well. We sub in a 2, remembering we don't have the 2 minus v, and we'll get 1 on 5. So we can do the same thing with the b. So we can times everything by 3 plus v. So if this was 3 plus v, you can see we would just get a b here. If we subbed in a negative 3, and this time we've got rid of that, we've times that across. We're just subbing in our negative 3 in here. So again, for b, we get 1/5. So for both 1 on a, so both a and b, we get 1/5. So I'll just put a little 1/5 here and cross that out, and a 1/5 here just to remind us, but we don't need that. All right, so let's go to the next one. So we've got this, all these words here basically, but they give us the dv dt or the acceleration. So we know dv dt or the acceleration is 10 to the power of 4 on the mass, which is 4.5 times 10 to the power of 6. And we've got 6 minus v minus kv squared. And clearly we're going to use this part up here at some stage in this question. Actually, while I'm at it, I might just have a look at what 2 minus v times 3 plus v is. So that's a 6. I get a minus v, and I get a minus v squared. All right. So that looks very much like this bit here where k equals 1. So here, this question says find k, and I'm hoping it is 1. Let's find out. So maximum speed. What happens to get maximum speed? When we've got the maximum speed possible, there's no longer any acceleration pushing it. So we're going to say the acceleration is 0 at that point. So let's make acceleration 0 and have a look. So it tells us the maximum speed is 2. So when a equals 0, we're going to have v equals 2. So let's put that in. So we've got a 0 here, and let's fix this up a little bit. So we're going to have 4.5 times 10 squared on the bottom there. Here we're going to have 6 minus 2 minus v squared is 4, so 4k in there. All right, so it actually doesn't matter what this is because we can just times it across to the other side and it's 0. So we know that in order for this to be 0, 6 minus 2 is 4. 4 minus 4k has to equal 0. Therefore, k equals 1, which is what we're expecting because now it kind of matches that fraction there, the denominator there. Okay, hopefully that makes sense. All right, so part 2, we have show that the body attains a speed of 1.5 starting from rest in a little over 2 minutes and 41 seconds. So you can see we've got time and velocity. So if we look at our acceleration, let's make it, we want time and velocity, that's fine, except on the right hand side it's all v's. So I'm going to tip it upside down. So I'm going to have a look at dt to v. That would be, so when I put that mass in before, I got 450, so that's going to be 450, and it's going to be on 6 minus v minus kv squared, just like this, 6 minus v minus 1 v squared, so exactly the same as that. So actually, I can actually put it, separate it, but I'll just write this first. So it is actually equal to that, which is the same thing as 450. So let's integrate here. So we've got the integral, and we're going to have a fifth for both of them. So I'll put the fifth on the outside, and we've got, so then we've got this one plus this one div. All right, so we could do 0 to v if you want, or just we could do it as is. So here clearly we're going to get a 90. Then we're going to get a log. Here we go. We'll put them together. So we're going to get a log 3 plus v minus a log 2 minus v. So it's going to be 3 plus v on 2 minus v, like so, plus c. If we did 0 to v, because we know it's happening in some from 0, so from 0 to v, you can see that when I sub v into that, I'm going to get that, minus when I sub 0 into that, I'm going to get log 3 on 2. So we could just put that there already. All right, now it did say show that. So the time, show that the time is 2 minutes 41 seconds. All right, so we're going to sub in our velocity of 1.5. So we've got 90. Here we've got log of 1.5, so 4.5 on 0.5 minus log of 1.5, 3 on 2. So if we wanted to, actually, we could put those logs together too. Here, really, I would just go to the calculator and put it in. So give that a go and just make sure you do get the answer. We should be getting it. Of course, you will get your answer in seconds because time here is in seconds. So just make sure. Actually, I quickly have a go. Let's see if I can get it right. 4.5 divided by 0.5 minus log of 1.5, and then we're multiplying by 90. All right, so here I get 161.258, blah, 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 blah. So you could do two things. You can say, well, there are 60, this is probably the easiest way, 60 seconds in a minute, so I'm going to divide by 60. And then I'm going to press the degree button. So when I divide by 60, I get, so this is seconds. So when I divide by 60, I will then get 2.8687 blah, 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 minutes. Press the bubble button, the degree minutes button, and you can see that'll mean you get 2 minutes, and it says 41. So 41 seconds there. Hope that helped.